Welcome back. For those who don't know me, my name is Osale Mahana. I'm a teacher of maths and I've taught A-level maths for the past 50 years. I just retired 2 years ago, and I thought I should record these videos for the benefit of students. Well, today I want to continue with the topic on algebra. So the topic is still algebra. What I am showing you now in the first lesson has got a bearing for what I am going to do next. So let's look at the principles of counting. I don't want to go into the theory because in the edXL syllabus we don't have it. I think permutation combinations, if you do S2, you have them. Anyway, what the fundamental principle of counting, meaning suppose I had 2 pens. I want to hold them in my hand. How many different ways can I hold it? One is red first, blue next, or blue first, red next. So therefore, if I have 2 things, I can arrange them in 2 ways. Suppose I had a red, a blue, and a green. How many ways can I arrange it? Look, green, blue, red, 1. Green, red, blue, 2. After all the greens, red, green, blue, 3. Each one must be different. And then red, blue, green, 4. I finish with green, I finish with red. So let's bring the blue. Blue, red, green, 5. Blue, green, red, 6. So if you have 3 things, I can arrange them in 6 ways. These are simple. Of course, arrange them in order in a line. Or I can also think of how many ways how many different ways can I pick 3 things, right? One at a time without repeating the order. So, in other words, if I want to, I could just show you out of interest. Blue, green, red, blue, red, green, green, red, blue, green, blue, red, red, blue, green, red, green, blue. So I can pick them, or either arrange them in a line, or I pick them one after the other. Right? That is 6 ways. Now suppose I just increase only by 1. I have now got 4 things. Pretty interesting. So let me put the 4 things. Black, green, red, and blue. I'll use L for blue so that there are no 2 B's. So the separate thing, there's no repetition. Each one is different from the other. And how many ways can I arrange them in a row, or how many different ways can I put them in my pocket to fit nice like this? Or, so maybe it's blue, green, black, green, red, blue, or black, green, blue, red. Black, red, green, blue, black, red, blue, green. Black, blue, red, green, black, green, red, blue. Yeah? Is there something else missing? Black, green, red, blue, black, green, black, green. Let's go systematically. Sorry. I know there are more. I just want to take some. So First I'll fix black and green, I don't change. I can do red and blue, that's already there. That's one. The second one is black and green, blue and red. Now I will make black and red, blue and green, green and blue, black and red, blue and green. Or I can do black and blue, red and green, black and blue, green and red. 1, 2, 3, 4, 5, 6. That means if I pick a black first, I have 6 of them. If I pick a green first, I will have another 6. If I pick the red first, I will have another 6. If I pick the blue first, I will have another 6. So 6 times 4. So I can say 4 things can be arranged in 24 ways. Imagine how or what the problem would be if you're just 5 things. People want to sit, the family, dad, mom, a son, a daughter, and the family dog. They want to sit on a chair to take a photo. Dad says, no, I want to be next to the dog. Mom says, no, I want to be next to my son. Fine. And then the son says, Mom, in the last picture you were next to me, now I want the dog next to me. She wants to take a picture. Or suddenly the son and daughter say, look, we want to be in the middle, dog in the middle, dad you come here, mom you come here. Then the son says, look, it's men on one side, women on one side, segregation, no. Dad, sis, dog, me, mom. So they think of so many possibilities. Do you realize how many are there? There are about 120 possibilities. How did I come up with that apart from the fact that I am a genius? Yeah? But there is an easier way. Suppose, therefore, in other words, I've got 5 things and I have to put them in 5 chairs. Dad, mom, son, daughter, dog. I have, by the way, in one of these lessons, I'll bring the dog here. They've got a mascot in this office. He's a lovely dog. His name is Midji. I will show him. I'll show you one of these. I'll bring him over here just to say hi to you. So look, so we start from the first chair. From the first chair, I could put dad, or I could put mom, or I could put the son, I could put the daughter, or I could put the dog. So there will be 5. But only one person can occupy. So one person is occupied there. Now I left with 4 people. Okay? Then I can put any one of the 4. So I have filled 2 chairs. The next one, 3. Because out of 5, I've already filled in 2. So I have 3 people. And the next one, 2. And ultimately, if dad, mom, daughter, son sit there, the dog has to sit there. So this is, in other words, first one, I have 5 choices. For the first one, there are 4 choices. For that one, there are 3 choices. For that one, there are 2 choices. For that one, there is 1 choice. So like that, I could do for that. So in other words, look, 4 times 3, 12, times 2, 24. 24 times 5, 120, which I can get directly by multiplying these. Well, now does that work with the 4? Yes. What is 4 times 3 times 2 times 1 is 24. Does that work with 2? Yes. 2 times 1. Does that work with 3? Yes. 3 times 2 times 1. Now, this is called the fundamental principle of counting. So, if you have n things and you want to arrange them in a row without repetition, the various different arrangements, that means each arrangement must be different from the other arrangement, then you can arrange them in n factorial ways, we call it. A factorial, n factorial means n times n minus 1 times n minus 2 times n minus 3 times n minus 4 up to times 3 times 2 times 1. So this would be 5 factorial, that would be 4 factorial, that would be 2 factorial, and that would be 3 factorial. So that's the fundamental principle of counting. That means n things can be arranged in a row without repetition in n different ways. N factorial different ways, sorry. Then comes the question, so why are we learning this? Hang on, you'll learn something new as well apart from this, because they are going to be helpful to us at a later stage in the next lesson. I need the background for the next lesson. So this is more to do with trying to introduce you. So in other words, I can put it as n factorial means n times n minus 1 times n minus 2 times n minus 3, etc. 3 times 2 times 1. That is n factorial. Now let's go back to simple things. Again, this is a very important topic in maths, very useful everywhere, especially in statistics, arrangements and probabilities and so on. Suppose I had 3 things. I'm picking 2 out of 3 things, one at a time. Remember, I'm picking, there are 3 things. What's this? Red, blue and green. Red, blue and green are the 3 things. I want to pick 2 of them, one at a time, not 2 at a time, one at a time. How many different ways can I pick? I can pick red and blue, or I can pick red and green, or I can pick blue and red, blue and green, or I can pick red and green, blue and green, or I can pick green and red, or green and blue. There are 6 different ways. Again, how? I want only now 2 places to be filled. The first place I can fill with any one of those 3. Once I have picked one, I have 2. Right? This is a number of ways in which I am picking 2 things out of 3 things, one at a time. Very important, the word one at a time. That means the order in which you pick is very, very, very important. So therefore, this is written as 3p2, or some textbooks use 3-2. Don't confuse it with coordinates. 3p2 means the permutation. It's called a permutation, different arrangements. So it's a permutation of 2 things out of 3 things, meaning you're picking 2 things out of 3 things, one at a time. So you got the answer as 3 times 2, right? Can I write it as 3 times 2 times 1 over 1? Would I be wrong? So, what is the relation between 3, 2 and 1? 3 minus 2 is 1. So, can I write this as 3 factorial over 3 minus 2 factorial? Well, you just cooked up some number, made it 3 and 2, it worked. Does it work with 5? Okay, let's see. So now, I've got 5 things. Let me see if I have 5 things with me. This is 4. Yes, there. I've got 5 things now. Out of these 5 things, I want to pick 2 of them. That means I'm looking at, so let me just put the formula which I showed you. 3p2 is 3 factorial over 3 minus 2 factorial. So now I've got 5 things. What are they? Blue, red, green. Now I got a black. Okay. Black, red, green, blue and purple. I want to pick any 2 of them one at a time. That means picking black first, purple next, is different from picking purple first, black next. Let's do, so in other words, look, it's going to be mind-boggling. Black, purple, or purple, black, 2. Then black, blue, blue, black, 4. Black, red, red, black, 6. Then black, green, green, black, 8. Then I've done all the black. So red, purple and blue, blue and purple. Purple and red, red and purple. Purple and green, green and purple. You're going to take ages to do it. So in other words, go back to the same logic. I have got to pick 2 things or place them in 2 boxes. 1 box, each box contains 1 only. So for the first box there are 5, the second box there are 4. So I can say this is 5p2. What is 5p2? Number of permutations or the number of ways in which you can pick 2 things out of 5 things, one at a time without repetition. That means the order of picking is important. So therefore that would be 20. But how did I get 20? 5 times 4. Now, if I write this as times 3 times 2 times 1 and divide by times 3 times 2 times 1, would I be wrong? The 3 to 1 will cancel, I'll still get 20. Yeah? But that would be 5 factorial over 3 factorial. What the relation between 5, 2 and 3? 5 minus 2 is 3. So therefore, 5p2 is 5 factorial over 5 minus 2 factorial. Well, let's do it the other way. I don't want to increase too many things, so let me take 4 things. I want to pick, does it work? So according to this formula, 4p2 must be 4 factorial over 4 minus 2 factorial. 4 factorial, that is 4 times 3 times 2 times 1 over 2 factorial is 2 times 1. So the answer must be 12. So if I have 4 things and if I have to arrange 2 of them or pick 2 of them one at a time without repetition, I must get 12 different possibilities. Okay? Let's look at that. Black, red, I don't want to use black, I'll use blue, red, green and purple. Okay? Let's now, I'm keeping it very simple. I'm not going into theory of permutations and combinations, just introducing you to how interesting maths could be. Right. I can do black and red or black and green or black and purple. So the first one I'm picking is black. Sorry, not black, blue. So first one I'm picking is blue. Then I can put blue and purple, blue and red, blue and green. 3 possibilities. Now I keep this back. I have done all with the blue. I want to pick purple first. If I pick purple first, then I can do purple and blue, purple and red, purple and green. So I've got 3 for this, 3 for this, 3 for this, 3 for this. How many do I have? 12. And this answer we got was 12. With small numbers we can do it, but what if we had a class of 20 people and you have to decide something like, you all play cricket, football, I think more football than cricket. There are 11 people, you have to choose a position. Me being a goalkeeper and you being a goalkeeper will make a big difference, because if I am the goalkeeper, your team will lose by 150 goals. If you are the goalkeeper, perhaps the team might not concede a single goal, because I think he is Schumacher, the best goalkeeper in the world. Yeah, someone like that. So therefore, the order in which you pick is important. So that is called a permutation. In other words, we have NPR as n factorial over n minus r factorial. I just take this to illustrate something else. Now instead, I want to pick 2 things out of these 4 things, but not 1 at a time, but 2 at a time. Meaning, if I pick blue and red, I have picked red and blue also. So therefore, once I pick blue and red, I don't have to consider, I have to list everything. I'm sorry. Red and blue. Should I list it? Okay, let's list it. Red and blue, red and green, red and purple, green and blue, green and red, green and purple. So once I pick blue and red, I don't need red and blue. Once I pick blue and green, I don't need green and blue. Once I pick blue and purple, I don't need purple and blue. Once I pick purple and red, I don't need red and purple. Once I pick purple and green, I don't need green and purple. Once I pick red and green, I don't need. So how many do I have? 1, 2, 3, 4, 5, 6. In other words, this is slightly different. The number of ways in which I am picking 2 things out of 4 things, 2 at a time. That means the order AB is the same as BA. Red green is the same as green red, so I don't count it twice. Then what will happen is, so if I had 4p2 is 4 factorial over 4 minus 2 factorial, which the formula was, then look, previously I had 12. Now I have only 6, so I divide by 2 or 2 factorial. That is called a combination NCR equal to n factorial over n minus r factorial r factorial. I want to stop there because before I start binomial theorem, I want to show you certain things on that. There's not going to be any handout on this. It was just a discussion to introduce you to principal accounting, permutations and combinations. The one formula, if you want to, for the next lesson, you will see all this is rubbed off, but you will have that formula somewhere in the corner. I'm going to use it. So let's continue in the next lesson on binomial expansion, and we will link it to this. Thank you very much. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.